Hello friends, welcome to my channel. We have a problem of JEE Advanced 2019. We have given that determinant of given a square matrix 2 cross 2 a square matrix is equals to 0 for some positive integer n, and we have to calculate summation k equals to 0 to n nck over k plus 1, where ncr denotes the binomial coefficients. So first of all, we have we calculate all the entries of the given matrix. So first of all, we know that k equals to 0 to n. Summation k can be written as 0 plus 1 plus 2 plus n, and this is equals to n into n plus 1 over 2. This is the sum of the first n natural number, and this is known formula for us. So again, we are going to find out the. So first of all, we know that the expansion of 1 plus x raised to power n is equals to, so expansion of 1 plus x raised to power n is equals to k equals to summation k equals to 0 to n n c k x raised to power k. If we take it as first equation, so if we differentiate both side with respect to differentiate 1 both sides with respect to x. So this is n into 1 plus x raised to power n minus 1. This is equals to summation k equals to 0 to n n c k times k x raised to power k minus 1. So again, if we put both side, put x equals to 1 in above expression, so this is equals to n into 1 plus 1 raised to power n minus 1, and this is equals to k equals to 0 to n n c k times k, and this is 1 raised to power k minus 1, and this is equals to k equals to 0 to summation k equals to 0 to n n c k times k. So and this is equals to n into 2 raised to power n minus 1, k equals to 0 to n summation k equals to 0 to n. This is n c k times k. Again, so take this as equation number 2. If we differentiate this as equation number 1, differentiate 1 plus x raised to power n d square over dx square, and this is d square over dx square summation k equals to 0 to n. This is n c k x raised to power k. So integral can be taken inside because this is convergent. Integral can be taken inside since this is a finite and continuous. So and this is equals to n into n minus 1. This is 1 plus x raised to power n minus 2, and this is k equals to 0 to summation k equals to 0 to n, and this is n c k k into k minus 1. This is x raised to power k minus 2. So put x equals to 1 both sides in this. So this is equals to n into n minus 1. This is 2 raised to power n minus 2, and this is k equals to 0 to summation k equals to 0 to n n c k times k into k minus 1, and this is, so again this is equal to, we can write this as summation k equals to 0 to n n c k times k square minus this is k equals to 0 to n n c k into k, and this is, and we have known that, so summation k equals to 0 to n n c k k square is equals to n into n minus 1 summation 2 raised to power n minus 2, and this is plus, and the value of this is n into 2 raised to power n minus 1. Again, take n into 2 n into 2 raised to power n minus 2 as a common factor, and this is n minus 1 plus 2, and this is equals to n into 2 raised to power n minus 2 n plus 1. So this is equals to n into n plus 1 raised to power into 2 raised to power n minus 2. So thus we have obtained that. So obtained the value of k equals to 0 to n c k square, and take this as, so this is equation number 2 to, so take this as equation number 3. Again, in the expansion 1 plus x raised to power n summation k equals to 0 to n ck x raised to power k, if you put x equals to 3, both sides we get, this is 4 raised to power n, this is, if we put x equals to 3 both sides, this is 4 raised to power n, and this is k equals to 0 to summation k equals to 0 to n ck 3 raised to power k. So this is, take this as equation number 4. So using these equations, so determinant of, so entries of determinant is, so determinant is equals to 0, and entries are n into n plus 1 over 2. This is, and by equation number 3, so by equation number 2, we have obtained that nck is n into 2n minus 1, and this is nck, and by equation number 3, this is equals to n into n plus 1, sorry, this is n into n plus 1, this is 2 raised to power n minus 1, and this, and the value of this is n into 2n minus 1, sorry, this is 2 minus 2, and again the value of this is 4 raised to power n. So by determinant of 2 cross 2 a square matrix is very simple. So we can multiply, we can obtain the determinant by n into n plus 1 by 2 into 4 raised to power n minus, this is n into 2n minus 1 into n into n plus 1 2 raised to power n minus 2 is equals to 0. So we can take, now we can, this is equals to n into n plus 1, and this is 2a square 2 raised to power 2n, and this is minus 1, and this is n into n plus 1, n square into n plus 1, and this is 2n minus 3 is equals to 0. If we take n into n plus 1 2 raised to power 2n minus 3 outside as a common factor, so this is 2a square minus n is equals to 0. So we have n into n plus 1, so n minus 4 into 2 raised to power 2n minus 3 is equals to 0, and we observe that this, for any natural number, this is not equal to 0. So we have n is equals to 0, n plus 1 is equals to 0, n minus 4 is equals to 0. So we obtained that n is equals to 0, n is equals to minus 1, so n is equals to 4. So again, we have observed that, so we have to find out the value of, in the given problem we have to find out the value of nck over summation k equals to 0 to n nck over k plus 1. So we know that 1 plus x raised to power n is equals to k equals to 0 to n nck summation x raised to power k. So if we integrate this expansion, integrate both sides with respect to both sides from limits, within limits 0 to 1. So this is 0 to 1, 1 plus x raised to power n dx is equals to, this is, and n is equals to 4. So we have obtained, this is, take it as 4. So k equals to 0 to n nck integration 0 to 1 x raised to power k dx. So, and this is equals to 1 plus x raised to power 5 over 5, and limits varies from 0 to 1, and this is k equals to 0 to n summation k equals to 0 to n, and this is xk plus 1 over k plus 1 nck, and limit varies from 0 to 1. So this is equals to 1 plus 1 raised to power 5 over 5 minus 1 plus 0 raised to power 5 over 5, and this is equals to k equals to 0 to n, and summation, this is n c k over k plus 1, and this is 1 k plus 1 minus 0 k plus 1. So again this is equal to, so value of this is equals to 2 raised to power 5 minus 1 over 5, and this is summation k equals to 0 to n nck over k plus 1, and this is equals to 32 minus 1 over 5, and this is k equals to 0 to n summation n ck over k plus 1. So and value of this is equals to, so value is equals to, so we have obtained that k equals to 0 to n summation k equals to 0 to n nck over k plus 1 is equals to 31 over 5, and this is equals to 6.2. So this is the answer of the given problem. Thus we have solved the problem. Thank you.